All right, we start off with graphing, with factoring by GCF, okay? GCF, what is GCF? Greatest common factor, and I'm going to write that down. GCF. Greatest common factor. And you want to get to the point that you can look at a term and a couple of terms and know what the greatest common factor is, but you might not be there yet. So there's a method you can use if you have to review. And here it is. Here we have a binomial. It's a quadratic binomial. And we're going to factor this by GCF. Well, let's see. I'm going to break down the first term, 12, into 4 times 3 times S times S. And I could break that down, the 4 down into 2 times 2 if it were necessary, but notice you have a 4 in the other term. And I'm going to put times 1. It's always a good idea to do that. Here's why in a minute. The way we set up factoring by GCF, we put the GCF first, usually. Then we put parentheses, and then we put the leftovers. And you'll see what I mean by that. All right, so first I have to decide what the GCF is. And I look at each term and I see that both terms have a 4 and both terms have an S. And for that reason, a 4 and an S and a 4 and an S is or are the GCF, okay? So I'm going to write down 4S and then parentheses. What's left in the first term? There's a 3 left and an S. So the leftovers of the first term are 3S. In the second term, I have a 1 left over and a plus sign in the middle, so plus 1. This is the factorization of 12s squared plus 4s. Now notice what would happen if I were to check this. If I were to check my answer, here's how I would do it. 4s times 3s plus 1. I would distribute and distribute. 12s squared plus 4s times 3s is 12s squared, and 4s times 1 is 4s. Now, if I get what I started with, which is 12s squared plus 4s, then I factored correctly. What you do when you factor is you ask yourself, what was multiplied together so that I got this answer? This is the answer, and you have to go back to the original multiplication that gave you that, or the original distribution that gave you that answer. That's what factoring by GCF is.
Can I ask a quick question real quick?
Absolutely.
Do you only use the 1 if it's not squared, or like with the 4s? If it was 4s squared, would you still need the 1?
No.
Okay.
No. It's just I kind of looked ahead and I saw, well, there won't be anything left if I don't put the 1 there. And then you're going to ask, well, where did you come up with the 1? So this sort of was my way of trying to avoid mixing people up. Because it is true that 4s times 1 is 4s. So you can always go ahead and put times 1 on a term anytime it's convenient. Does that answer the question?
Yes, thank you.
Okay, good. Okay, so here we are. And I'm going to go ahead and put the answer over here. 4s parentheses 3s plus 1. And this is your first homework problem. Notice I printed off the first homework sheet for this week, which is week 5. Welcome to week 5. There you go. And I might as well write solutions up here. Most of the time I need more room than I can get, so I don't just print off the homework sheet. And indeed, for the next set of homework, there are 2 for this week, which isn't extravagant at all. We are, for the next one, I'm going to need more room, but probably I won't need more room for this, so I can write directly on the sheet. Okay, here we have a quartic binomial. Highest power 4 is quartic, and it's a binomial because there are 2 terms. All right, I'm going to do this the easy way. The first term is y times y times y times y, plus the second term, which is 4 times y times y times y. Notice that this is y to the 3rd, and this is y to the 4th. And y to the 4th automatically contains y to the 3rd. Here it is right here. Y to the 3rd. I'll write it in blue. Y times y times y. So the lower power, when you have 2 y terms, the lowest power will always be at least part of the greatest common factor, the GCF. So both terms do indeed contain y to the 3rd. So I'll go ahead and do this too. Y, 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 and therefore y to the 3rd will be my GCF. Now, I write the leftovers. There's 1 y left here. Shouldn't circle it because I circled the ones I was taking out before, so I really need to be consistent. Y to the 3rd and y to the 3rd gives me y to the 3rd, and I am left with 1 y in the first term and a +4 or a +4 in the second term, And I can't break this down any further. Let me check and make sure it's true. Well, let me start up here. I start out with y to the third times y plus 4. So that'll give me y to the third times y plus 4 times y to the third. Now this, I'm also helping you review the rules about powers. This is y to the third times y to the 1. Y to the third times y to the 1 is y to the 3 plus 1. That was the very first rule of exponents you ever learned. Three plus 1 is 4. I've always been told that. So y to the 4 plus 4y to the third. Most people just do this part in their head, okay? By the time you're in college algebra, at least half the class can do it in their head. But some of you can't, because it's been a while. So this is what you do when it's been a while. And it's a good way to review the rules of exponents. So anyway, this checks, this is what I started with. Y to the fourth plus 4y to the third. So I know that this is my answer. Y to the third, parentheses, y plus 4, close parentheses. Do you have to check? No, but it's a really good idea. At least if it's been a while. Okay. Any questions? Just stop me if at any point I start going too fast for you. All right, here we have a binomial. It's a quartic binomial. This really should be written the following way. Negative 3a, to the fourth, plus, because that's positive, 9a squared. This is a polynomial, and it's normal to write it in, I mean, it's preferred to write it in descending order. But you know what? People who write books do not always do things the preferred way. So I'm not going to make a big fuss about it, but I'm telling you the correct way to write that is this way. But we're going to ignore it. Yes, we are, and show how tolerant we are. Picky math teachers. I'm going to factor, I'm going to totally break down each individual term. 3 times 3 times a times a minus 3 times a times a times a times a. Both terms contain a 3. And both terms contain 2 a's. So my GCF is going to consist of 1 3 and 2 a's. A times a is a squared. Now what's left over is, there's a 3 right here, and a minus sign. And there are two A's here. So A times A. So my answer is going to be 3A squared. 3A squared parentheses 3 minus A squared. So I can check this by redistributing. 3A squared times 3 is 9A squared. And 3A squared times negative or minus A squared is going to be negative 3A squared times A squared. And just going through all the steps to help you remember the rules of exponents. 9, 9. Well, it looks like an A. Beware of numbers and letters that look alike. They're out to get you. A squared times A squared is A to the 2 plus 2. So our answer is 9A squared minus 3A to the 4th. And I look back at what I started with, 9A squared minus 3A to the 4th. So indeed, I did factor correctly. That's my whole reason, is to double check my hypothesis, which is what an educated guess is called. Okay, this is basic GCF stuff that we've just done. Let me make it a little smaller here so we can see the numbers. Problem number 1, problem number 2, and problem number 3 in your homework entitled 4.0 Homework, Review Factoring Trinomials, A equals 1, also u-Substitution and difference of squares. That will be all explained to you. But we now are going into something more complicated. We're still going to factor by GCF, but there's an extra rule. These were all basic, very basic GCF factoring problems. But we enter a new level of complication. When the leading term is negative. Now let's review leading term. Leading term is the highest degree term. Let's review degree. Degree and power, when you're talking about the individual term, are the same thing. So the degree of this term is 1. The degree of this term is 0, because constants, numbers without letters, constants are always degree 0. And there's a complicated reason for that I am not going to go into right now. We probably will at some point. You've got the same thing here in number 5. You've got degree 1 and degree 0. Which means, I mean, the whole reason I'm doing this, the highest degree term is called the leading term. And I need to write that down for you. The highest degree term is called, starts with a C, not an A, is called the leading term. You only have one, so it's the leading term. There's more. The coefficient, the number in front of, the coefficient of the leading term is called the leading coefficient. Now, this is only our first look at how incredibly important it ends up being. Well, the leading coefficient ends up being one of the very most important parts of polynomials. It actually determines stuff. As strange as that seems. I always thought it was strange, but it's true. All right, so our leading coefficient is -3. Did I say negative? It is negative. Leading coefficient, I'm just going to say coef, is -3. We're analyzing right here. We're doing something called analysis, which is what we're going to be doing more and more. This leading coefficient is -5. Leading coef, I'll tell you why it's important here in just a minute, but let's do some analysis. I forgot to write coef. All right, fine. Leading coefficient is -5. Now here, look at this. This is a trinomial. It's got 3 terms. The leading term is a cubic, which is degree 3. The next highest term is linear. They all, well, no, they don't all have different names, but these do. And this is called a constant. So you have a trinomial that consists of a cubic term, a linear term, and a constant term. You can look at the exponents and see that this is degree 3. See, there's really more review going on here than I let on. This is degree 3, this is degree 1, and this is degree 0. So -3s to the third is the leading term. Leading term -3s to the third, and the leading coef, the leading coefficient, is -3. Okay. When the leading coefficient is negative. All right, this is a big important rule for you. I'm going to write it down here so I can write it really big. When the leading coefficient, number in front of the leading term, leading coefficient is negative. The GCF, the greatest common factor, is a little different. The GCF must be negative. This puts in a whole new level of complication. Yes, it does. So let's start with number 4. Negative 3b plus 6. If the GCF has to be negative, then I have to find a negative number in the second term, which is positive. Can I do it? Yeah, I can. This is going to be negative 3b plus negative 3 times negative 2. Negative 3 times negative 2 is positive 6. There's no choice, you have to do this. Okay. Now I can look at term 1 and term 2 and say, aha! Both of these terms contain a negative 3. So this is going to equal negative 3 times b, and that's the leftover in the first term, and negative 2 is the leftover in the second term. And of course, we don't write signs, operation signs together. So that means our final answer is going to be negative 3, parentheses, b minus 2. We're going to do this again 2 more times. But let's look at this. Let's check the answer. Negative 3, well, here, let me write this. Negative 3 times b minus 2. Negative 3 times b is negative 3b. Negative 3 times negative 2 is positive 6. Kind of there. And negative 3b plus 6. Negative 3b plus 6. Negative 3b plus 6. Yes, it's what I started with. So that means this factorization is correct. Negative 3, parentheses, b minus 2. There you go. Okay, let's do it again. Kind of get the feel for it. I start out with negative 5s minus 10. Now my life is going to be easier, and I love it when my life is easier. If I rewrite this right away as negative 5s plus negative 10. Well, why will it be easier? We're about to see. I need to find a negative 5 in here to be able to pull it out with this negative 5. There is a negative 5 in there. Negative 10 equals negative 5 times 2. That's what I'm going to write next. So negative 5s minus 10, what we started with, equals negative 5s plus negative 10, negative 5, I'm sorry. Equals negative 5 times positive 2. All right, I've got my GCF. Each of these terms now has a negative 5. I pull out the negative 5 to the front and then make parentheses for my leftovers. S is the leftover in the first term, and positive 2 is the leftover in the second term, and this is my answer. Now, if I check my answer, start with negative 5 times s plus 2. I distribute negative 5 to the s and to the plus 2. What I get is negative 5s, and negative 5 times plus 2 is negative 10. And that is precisely what I started off with. So I am going to write this here, and in my math lab, this is the answer box, the blue answer box. Negative 5 parentheses s plus 2. Let's do one more, and then you can ask about these. I just want you to see how it works with a trinomial. Now we have 3 terms that we have to break down, and 3 terms that we're going to have to find some kind of negative GCF in. So you go one step at a time. Negative 3s to the third plus 12s to the 1 plus negative 24. Now I need to find a negative. Notice, remember that in a polynomial, terms are separated from each other by plus signs. So this is really what this polynomial is. This is the first term, this is the second term, this is the third term. Now I have to find a -3 in all of these terms. I'd love to find an S in all of these terms. There is an S there, but there's not an S here. So, you know, I'm gonna rewrite this in this way. -3s to the third plus. Now 12 can equal -3 times -4. -3 times -4 is +12. And then I have to try to not forget the S. Plus, -24 can be written as -3 times +8. So double check, -3s to the third. This is +12s, yes. And this is -24, yes. Now I see that there is a -3 in all three terms. I pull that out to the front. And then I write the leftovers in each term. I have s to the third. Well, try to stay consistent. S to the third plus -4 s plus 8. That's a +8. Well, the plus and the minus next to each other. Just say to yourself, well, positive times negative is negative. So our final answer, my final answer, is going to be s to the third minus 4s plus 8. There you go. And to do a quick check, that'll be -3 times s to the third is -3s to the third. -3 times -4s is +12s. -3 times +8 is -24. So that checks out. So this is going to be the answer I write in the answer box. -3 parentheses, s to the third minus 4s plus 8. Okay, notice there are lots and lots of rules from the past that you have to start remembering to do this homework set. You've got to remember the basic rules of exponents, and you've got to remember that the rules of multiplying integers. Negative times negative is positive, negative times positive is negative, positive times negative is negative. So that's not a lot to remember from the past, but it is something. All right, ladies and gentlemen, this has been Factoring by GCF. Problems 1 through 6 are GCF problems. And problems 1 through 3 are positive GCF problems. So I'm going to write that. Positive GCF. Why don't I just put a plus? Plus GCF for positive, and plus GCF. I like that better. So I'm gonna rewrite that. Yes, I hear a voice.
You're snoring.
Let me write for 4, 5, and 6, negative GCF, and negative GCF, and then we can talk. Okay, let's talk.
Professor,
Yes.
that number 7 down there, is that not factorable?
Yes, it is.
Okay, could you?
But we're going to use it. We're going to use a different method.
Okay.
Thank you. That's a good intro. But any questions about what I did here? Do you want to talk about it? Like, why do it? Because what we need to do is get back to what made the thing happen. And it's more than that, but you'll find out in a week or two. Maybe more. No, a week or two. There is an important reason to do it, though. Please trust me with that. Yes. Am I going to hear a voice?
Yeah. Okay. So the only reason that you put the positive in front of the negative and then was to isolate the integer, right? And then we can just take out the positive.
Yeah, the whole idea is to find a way to isolate the positive GCF. Now, if you already see it, you know, you can just do it. But this is assuming that there are people in the class who don't remember. So I want to put it down in very basic terms, what your brain should be doing. Does that answer your question?
Well, yeah, I was talking about the negative ones. When you stuck the positive sign in there, you can just take it right back out. It's for the sake of less confusion, right?
Right here, yes.
Yeah.
Because there is another rule that in polynomials, well, actually in just about everything, but in polynomials, terms are divided by plus signs, even when you don't see them. Divided. Terms are separated. Better term. Separated. Better word. See, there are math terms and there are English terms, and it can drive you crazy. In polynomials, terms, like that's a term and that's a term, and that's a term and that's a term. Terms are separated from each other.
Is that a mathematical constant? Like, does that have a proof by some mathematician somewhere?
I believe it's a proposition, which means it's just accepted as a basic fact.
Gotcha.
In polynomials, terms are separated from each other by plus signs. But that is such a good question. Do more research. Okay, that's why. That's why I can put in and take out a plus sign when I'm dealing with terms. The invisible plus signs are really there. So it's a matter of rewriting this negative 5s minus 10 the way it really is. There is a plus sign there. It's just that we don't write it because we're all supposed to know it. Somehow we were born knowing it. I wasn't, but maybe you were. More questions? Okay. Now, we're going to an entirely different method. Not that GCFs aren't important, and they will keep popping up from time to time, a lot of the time. But right now, we are factoring by a method called grouping when little a equals 1. So we need to kind of give that an explanation, I know. I just need to pull that down long enough to write. What's A? Well, it does complicate things that they're using the letter B here. So what I'm going to do to uncomplicate it when I'm explaining it is I'm going to change this letter to X and this letter to X because I need to use the letter B for a formula. Okay, so I can't have these people running around sticking A's and B's in instead of X's. So we're pretending all of these variables are X's just for now, so you don't get confused with what I'm about to say. Because I need the letters A, B, and C. See, look at what they're doing. Why? Why? What kind of sadist would do that? Not me. All right, now there's a good Y. I love Y, I love X, I love Z. But they shouldn't be using A's and B's, and someday I'm gonna have to write my own math book. Okay, here we go. We are dealing with a quadratic trinomial, which I have rewritten as x squared plus 9x plus 18. For the following reason, the formula for a quadratic trinomial, quadratic because the highest power is 2. The formula for a quadratic function so I'm just going to say quadratic trinomial. It's a trinomial. Tri means 3. There are 1, 2, 3 terms. And they are a little beastie in and of themselves. Formula for quadratic trinomial. Here it is. AX squared plus BX plus C. That is the universal formula for a quadratic trinomial. The highest degree term is 2. A is the number in front. It's the leading coefficient. Followed by a linear term, B is the number in front. Followed by a constant term, C is the number out here. So, what's the number in front of x squared? It's an invisible 1. In this quadratic trinomial, A is 1, B is 9, and C is 18. So this falls into the category of A equals 1. We're going to use a method of factoring called grouping, but it's especially easy when A equals 1. A will not always be 1. Be warned. Okay. I'm going to write it down here so I have room to move down. So it's 1x squared plus 9x plus 18. And what this is going to equal. When I have a 1 here, this is what I do. It has to be a trinomial. It has to be quadratic. I take the x squared and I split it up like this. Now here's what I do. Have to put this in words at least once. Factor, that is break apart, factor 18, the C number, into factor pairs. Oh, I am at the end. Factor pairs. Here are the factor pairs of positive 18. Now I'm making this a little harder than it is because I want to give you the complete approach. This is a quadratic formula in which A equals 1. A quadratic formula. This is a quadratic trinomial in which A equals 1. So I make the two parentheses. This is assuming it's factorable, right? I make the two sets of parentheses and I split the x squared apart into x and x. And then I look at the C number and I factor it, maybe mentally, into factor pairs. Here I go. 18 equals 1 times 18, 2 times 9, 3 times 6, 4 no, 5 no, and then it starts again at 6. So these are factor pairs. Now it also happens, to show you the complete picture, it also happens, since 18 is a positive number, that there are more factor pairs. -1 times -18, -2 times -9, and -3 times -6. These are all the factor pairs. We don't use fractions. These are all the factor pairs of 18. This is what I need. I need a factor pair that has two numbers. Of course, they all have two numbers each because that's what a pair is. I need a factor pair in which both of the numbers add up to the middle term. Three and 6. 3 plus 6 equals positive 9. And positive 9 is my B number. So what we do next is hit another problem. Okay, so what we do next is find a pair, find a factor pair that adds up to the B number. Which in this case is 9. So that would be 3 plus 6 is 9. So I'm going to use 3 and 6. They are my bingo numbers. They're both positive. So I put a plus 3 and a plus 6. And I'm done. That's all there is to it. Now, I should check my answer. I mean, if you want to be careful, you want to check your answer. I'm going to multiply x plus 3 times x plus 6. X squared plus 6x plus 3x plus 18, and that equals x squared plus 9x plus 18. So yes, that's the answer. That is what I started with. Right up there. Okay, now the hard truth here is that if I write x squared plus 9x plus 18 in the answer box, I'm going to get a great big error message. Because the original letter, I mean, I changed it. The original letter was B. So these people have no sense of humor at all. I'm going to have to change the letter to B. But I don't approve at all. This B is not the same as the B in our universal formula for a quadratic trinomial. Just so you know. Let's do it again. Suppose we have to come down here. I'll erase this. Okay. And then I'll rewrite it temporarily. Now in this, A is 1. That makes it easier. B is negative 13. Remember, there's an invisible plus sign there. So negative 13 is the coefficient of A. And C is 42. Okay, now, what I have to do is analyze 42. I'll come down here and do it. 42 is the C number. Well, what it equals is, and it's positive 42, very important. 1 times 42, 2 times 21, 3 times 14, yeah. 4 times, no. 5 times, no. 6 times, 7. 8 times? No. No. Well, I'm having a brain, you know what. 8 doesn't go into 42, does it? Or does it? I absolutely forget. That's why we need our friendly calculator to get us out of jams like that. 42 divided by 8. No, see, there's a decimal. That means 8 does not go evenly into 42. Okay, I'm going to pretend I knew it all along. All right, 8, 9, 10, 11, 12. Nope, okay, we're going to stop there. And then remember that, well, it's a positive number, so I also have negative factors. Negative 1 times negative 42, negative 2 times negative 21, negative 3 times negative 14, negative 6 times negative 7. And we need negative 13. Aha! Negative 6 plus negative 7 equals negative 13. Bingo! So, I come back up here and I put a negative 6 in here and a negative 7 in here, and then I go ahead and check. X minus 6, X minus 7 is going to equal X squared. Well, here, let me show you with my little arrows here. I take X and multiply it by X. I take X and multiply it by 7. Then I take minus 6 and multiply it by X, and minus 6 and multiply it by negative 7. And so that gives me X squared minus 7X minus 6X. Negative 6 times negative 7 is plus 42. And so X squared minus 13X plus 42. And that's what I started with right here. And I would like to write the answer like that, but no. Instead, I'm going to be writing it as boom, 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 boom. A minus 6 times A minus 7. See? A equals 1. A equals positive 1. More to the point. All you really have to do is factor the C number and come up with the pair that adds up to the B number. And then you've got it made. Okay. I mean, it's just a method. There's no deep thinking that goes into it. All right, let me take care of this. Rewrite it as x squared plus 5x minus 36. And now we're going to factor C, but remember that invisible plus sign. This is negative 36. We're going to factor negative 36. Let me do it down here. Negative 36 into factor pairs. So here's how I do it. I pretend for just a minute that this is positive 36. And I just write down the positive factors. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Then I remember that 36 is negative. Wait a minute, that changes the whole game. One of these factors has to be, well, one of these numbers in each pair has to be negative, and one has to be positive for me to get a negative answer, because negative equals positive times negative. So, in the first group, I make the first number negative, and then I write them again, and in the second group, I make the second number positive. I mean, negative. The second number negative. So, positive 2 times negative 18, positive 3 times negative 12, positive 4 times negative 9, and positive, well, I mean, they're the same, right? Positive 6 times negative 6. Kind of the same. Okay, so all I have to do is find the two numbers that add up to positive 5. And that's going to be negative 4 plus 9, because negative 4 plus 9 is positive 5. Over here, 4 plus negative 9 would be negative 5. So I'm going to go with these numbers right here and put a little negative 4 plus 9 equals 5, the B number. All right, so all I do is make a couple of parentheses, and I would put an X there, but of course I can't because the original letter is A. Okay. A and A. And then I choose my numbers from over here, minus 4 and plus 9. And then if I check it, which you probably always should, And A times A times 9 minus 4 times A minus 4 times 9. If you can't figure out whether this is going to be positive or negative, just use your calculator. Say 9 plus negative 4 or 9 minus 4, and you'll get a positive 5, which is what I started with. So I know it's a little boring to have me going through all of these. Oh my goodness. No, we're not going to do this. This is in the next group. I have that in there by mistake. This take, oh no, it doesn't. They're tricking us. I have to write this in descending order. And when I do, what do I get? I get a squared plus 7a plus 6. And just to get this out of the way quickly, 6 factors into 1 times 6, and 1 plus 6 equals 7. So do you see it can be that fast once you get used to doing it? That'll give you boom, 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 A, plus 1, plus 6. And then you can, that is the answer. But check it. Now here's another one like that. Here's one that's a little bit different. A is not 1. Oh, what am I gonna do? Oh no. Oh, have a drink of water. I have water today, not coffee. I'm already hyper enough. They're tricking you again. Because 2 goes into 2, 2 goes into negative 24, 2 goes into negative 56. Let's factor each of these terms. You've got a GCF. $56. Well, we needed 2, right? 2 into 56. It's 28. So, positive 2 times negative 28. There now. Look at that, you've got a GCF that needs to be factored out before you factor a quadratic trinomial. So let's do that. I'll factor out the GCF to the front, then parentheses, and write the leftovers from each term. Okay. I can even do something like mark out the 2 now, because I already wrote it down. That'll leave me with y squared plus negative 12y plus negative 28. Okay. Now I'm actually going to leave it like that for a reason. Okay, we have in the parentheses a quadratic trinomial, which is begging to be factored. We have 1 times y squared minus 12y, but our b number is negative 12. And our c number is negative 28. So we need to factor negative 28 into two numbers that add up to negative 12. Now, if I factored correctly, we're about to do that. Negative 28. Okay, I'm going to pretend for a minute that 28 is positive. And I'm just going to write the positive factors. 1 times 28, 2 times 14. No, 3 won't go. Will it? No. 4 will though. 4 times 7. 5 won't go. 6 won't go. And 7 will, so it turns around. So now I have to deal with the truth that 28 is really negative. So I'll make the first number negative, and then I'll write them again, but I'll make the second number negative. Okay. Now, which ones add up to negative 12? Right here. Negative 14 plus 2 is negative 12. So, my answer is going to be Y. Oh, no, it's not. I lied to you. That is the most common mistake you have. Instead, I'm not going to write it there right away. I'm going to go back here. Normally I would move down, but here I've got to move up. Y, positive 2, negative or minus 14. Now, this is the answer. You can't forget your 2. I almost did. And again, that's the most common mistake, so be careful. 2, parentheses y plus 2, parentheses y minus 14. Now let's look at how you would check this. Because you now have 3 things that you have to multiply together. This is a factor also. This is a factor, this is a factor, and this is a factor. This quadratic trinomial has 3 factors. Okay, so what am I doing? I'm doing check. I'm trying to write check. Check. Okay. I save the 2 until last. That's just the way I do it. Then I go ahead and I multiply these together. So I'll get y squared minus 14y plus 2y minus 28. I didn't need brackets, I could have used parentheses. This will be y squared. Notice I'm combining my like terms before I distribute in the 2. Negative 14y plus 2y is negative 12y. Minus 28. Then I multiply in the 2 and I'll get 2y squared minus 24y minus 56. And then I look and see if that's what I started with. 2y squared minus 24y minus 56. Yes, it works. So at that point I can click check answer and get told I did it well. Now, we should have taken a break, but wait for me because there are only 3 more problems. And in it, we use something of a new method. Let's get these out of the way, and then we can go to the much harder stuff. Why is it harder than this? Because the A number is not 1. Everything is harder when your A number is not 1. Well, here it wasn't 1, but it was a GCF. And then I made it into what, once we pulled out the 2, we had A equals 1. So this became much easier than the next group of problems on the next piece of paper will be. So now, a new method that's still, well, you'll see, it's still A equals 1. But it's a quartic. How can we factor a quartic? By using an ancient method called u-Substitution. Okay. Now, if you watch the book videos for this, you're going to see that Dr. Beecher, the lady, writes her U's like that. That's not a U, and she's doing that on purpose. That's the Greek letter mu. And before somebody decided to do what's called anglicizing, that is, say, well, it looks enough like a U, let's just take this little front tail off and we'll have a U and we'll call it u-Substitution, and we'll feel like it's one of our letters, not an ancient Greek letter. Okay, great, that's what's going on. It used to be mu substitution back in the early Middle Ages. And then it got changed. Well, so what? What is u-Substitution? We can do u-Substitution when the degree of the first term, let me find a different color here. When the degree of the first term is 2 times the degree of the second term. 4 is 2 times 2. Same thing for 6 is 2 times 3. And 8 is 2 times 4. When you have that kind of situation, you can use u-Substitution. And we're gonna. And here's how you do it. Okay. This is what you do. You let u equal t squared. So I'm going to write that down. U equals t squared. And then if I were to square both sides of this, I would have u squared equals t squared squared, which is t to the fourth. What does that do for me? This is what it does. That tells me that I can write t to the fourth as u squared, and I can write t squared as u, so that I can rewrite this whole thing as u squared plus 11u plus 10. I have just made that a temporary quadratic trinomial. Not only that, but a equals 1. So all we have to do is take 10 and factor into two numbers that add up to 11 in order to find u. And then, yeah, we have something else to do. But for now, it's going to be pretty easy and normal looking. So I'll have u squared. Let me write in black so it's easier to see. U does have blue has a kind of a glare. U squared plus 11 u plus 10. Now 10 factors into 1 times 10 and 2 times 5, and that's it. Of course, there are also the negatives, -1 times -10, and -2 times -5, but remember, you're not adding up to -11, you're adding up to +11. So 1 plus 10 is 11. So that means I'm going to factor this into u plus 1 plus 10. And that's the factorization of this. But what about this? U squared is t to the fourth. So this is, but we don't have a u squared. Dog. All right. This is all we're going to have to do. Plug t squared back in for u. T squared plus 1. T squared plus 10. Now, for those of you who have solved quadratic equations and quadratic-like equations, you're going to be tempted to solve that. Don't do it. These are not solving problems. You're not solving anything. All you're doing is factoring. So your final answer is going to be t squared plus 1 t squared plus 10. And then check your answer. Can we do it? Yeah. T squared plus 1 times t squared plus 10. Get my little arrows going here. Boom, and boom, and boom, and boom. And for those of you who are thinking, well, can't she factor it by the difference of two squares? No, but you're thinking good. If these were minus signs, then yes, I could. But they're not, they're plus signs, which makes them not factorable in the real number system. Otherwise known as prime. We can't go any further, but let's check the work. T squared times t squared is t to the fourth. How do I know that? Because t squared times t squared, they have the same base, so I can write it as t to the 2 plus 2. That's too small. T to the 2 plus 2, and 2 plus 2 equals 4, so that's t to the fourth. That's how I know that. All right, so t squared times t squared is t to the fourth. T squared times positive 10 times plus 10 is plus 10t squared. 1 plus 1 times t squared is plus 1t squared. And plus 1 times plus 10 is plus 10. So these are like terms. T to the fourth plus 11t plus 10 is what I hope I started with, and I did. Okay, do you absolutely have to use u-Substitution if you can do this without? If you feel comfortable doing it without, you don't have to use it. But most of us mere humans do have to use it. So here we go. 6 is 2 times 3. So I can let u equal b to the third. I'm going to try not changing the letter this time. Then u squared equals b to the third squared. Remember, when you have a base raised to a power and raised to a power again, you multiply the powers, and if you don't remember these, there's a chapter R for review in the very front of the book if you have the physical book, but it's in the very front of the book if you have the digital book, which you do have if you're on my math lab. So you can go back and review all the stuff you learned in beginning algebra and intermediate algebra. Well, not intermediate algebra so much, but beginning algebra. And that's what these rules are. Okay, so what I learned from doing this is that I can let b to the third equal u and b to the sixth equal u squared, and I can rewrite this as u squared plus 8u plus 12. And I'm going to factor 12 into two numbers that add up to 8, but I already know what it is. 2 times 6. 2 times 6 is 12. 2 plus 6 is 8. Some of these you can do right away. 2 plus 6 is 8. So take your u plus 2 plus 6. And then I go back and remember what I let u equal. I let u equal b to the third. B to the third plus 2 times b to the third plus 6. Now, for those of you who may have studied factoring by the sum of two cubes, you can't do that here. These are not perfect cubes. b to the third is a perfect cube, but these numbers, the constants, are not perfect cubes, so no, you can't. Okay, but good thinking, if you were thinking it. So our answer is going to be b to the third plus 2 times b to the third plus 6. And then you check it, but I want to get done with this so we can both take breaks. Well-deserved breaks. I don't know about you, but my butt is hurting. Okay. Now, here we have a smaller power. It's the p to the fourth that's going to equal u. Okay? So u equals p to the fourth, and u squared equals p to the fourth squared, which is 4 times 2 is 8, so p to the 8. So now I know that p to the fourth can be u, and p to the 8th can be u squared. And so what I'm going to have is u squared minus 9u plus 18. And a is 1. So this is going to end up being like this, u, and then we'll have to see. Because I need to take u, not you, you. Take u, that's a little math joke there. Take u, take 18, not take u, take 18, and factor it. All right, 1 times 18, 2 times 9, 3 times 6. Only there's also -1 times -18, -2 times -9, and -3 times -6. And this one adds up to -9. -3 plus -6 equals -9. So, I'll put this in black. -3 and -6. Now all I have to do is go to and put p to the fourth in here, and in here, because u squared is not called for in these factors, just u. So all I need is p to the fourth. So p to the fourth minus 3 times p to the fourth minus 6 is your answer. Once we start solving quadratic equations and stuff like that, yeah, you're going to have more involved, believe me, you're going to have more involved answers, but not now. All right, y'all, we're going to take a break. And then we're going to come back and have more fun with math. So I am going to stop recording because this video is long enough. Please, multiple people decide you're going to remind me to start recording again when you get back from your break.